Well, I screwed up. I used voice to text to put the title of the video in there, and I didn't proofread it. I think it says can profile, and I don't mean a girl's booty. But I am an ass man, I do like booties. So I wanted to talk about camshaft profiles a little bit, just touch on them, not actually profiles, just like what they do, and then talk about misconceptions about manifold pressure. So one of the misconceptions that people have, what's up man, about manifold pressure is they forget that just because you got 20 pounds of boost in the manifold doesn't mean there's 20 pounds of boost in the engine on the intake stroke. If there was, then you wouldn't need big cams, right? That piston is moving very fast, and the valves are small, relatively, right? The small opening at the skinny port and all that, and the piston has to suck that stuff into the chamber. Now, we're going to do basic NA first, right? But it's got to be able to suck that stuff into the combustion chamber. If cam profile didn't matter, and you always had the same manifold pressure you had in the cylinder, then you just have like a tiny little cam, right? Wouldn't matter. So what's the cam doing? Well, the cam is just getting that valve open longer and giving that difference in pressure more time to equalize. Essentially what's going on. Negating anything to do with momentum or inertia of the airstream or any of that. Just plain and simple, if I have a volume on one side of an orifice, I open that orifice, it's going to take a while for the pressure on both sides of that orifice to equalize. When a piston is moving up and down, you have very little time for pressure on either side of that orifice to equalize. So what you have to do is open the valve or the orifice longer or make it larger. And that's exactly what the camshaft is doing. It's taking that orifice, which is technically just the valves, and it's holding open longer, or it's holding open more, or both, right? Preferably both. And that gives more time for the pressure to equalize on both sides of the valve. Now, the reason that this is important is because of a conversation that I was having in text message with a friend of mine. Some engine management systems, and by some I mean pretty much all of them, that utilize a speed density function, they give you the illusion of accuracy. They tell you, oh, you've got this much grams per second of air, going into the cylinder, or your load is this or that or whatever. And they're not accurate. They can't be accurate. The only way that you can achieve any accuracy in a gram per second measurement is with a mass airflow sensor, or knowing exactly what the fuel density is at the time that is ingested into the engine. And from there, taking the air-fuel ratio at the tailpipe and back extrapolating that. Unfortunately, even that doesn't account for any air that may have gotten into the exhaust system during overlap and continues to burn in the exhaust afterwards. So air-fuel ratio isn't even completely accurate. So at best, it's gonna be fucking off, right? It can't be accurate. It can't be. It's fucking impossible. You have to have a system that has absolutely zero overlap, really fast sampling speed of your fuel density, and then really, really accurate sampling of your air-fuel ratio. And even that is subject to error dramatically, especially with changes in pressure. Exhaust manifold pressure affects your O2 sensor reading if it's pre-turbo. If it's NA, it could be in a system in the header, and the exhaust system has resonance in it, right? And so the pressure in the exhaust system goes up and down, and the reading of the air fuel sensor is affected by the pressure in the area that it's sensing. So there's errors there as well. So it's not accurate. And I think that's important for people to understand, that when they're gathering all the data that they can, there are some things that are outside the realm of modeling on a budget, right? Like, you can't model that without hundreds of thousands of dollars, or an accurate mass airflow sensor with a known calibration, because again, mass airflow sensor calibrations can change based on the piping air enters the pipe. Is the air in the pipe completely laminar and evenly distributed across the pipe by the time it hits the mass airflow sensor? If it's not, like it is on many systems, it's not laminar or perfectly even distributed, then your mass airflow sensor calibration won't be 100% accurate either. And so I have a friend who's very set on getting like the absolute numbers, and I tell him sometimes, like, yeah, dude, it's just not gonna, you're not gonna get it. That doesn't match because you can't have that data, right? And so I'm making this video mostly for him so that he can understand the other aspects of it. There's just error in fucking everything, right? And I think that's why the internal combustion engine is so amazing, and why you can go through tons and tons of books and research papers and stuff from professors. I mean, and they've got formulas that would blow your fucking mind, calculus that's super to describe what happens in the center, right? And all of that is still ideal, right? It only does so good of a job to capture and calculate the randomness that also is involved in that. So maybe I'm gonna get pulled over in front of you guys, I don't know. So like, there's only so much accuracy that you can get with the modern 0 to 5 volt sensors, with the air fuel sensors, with all that kind of stuff. I appreciate the streams, he says. When can I catch them? Oh, I catch what I need. We gotta see I'm moving again, and these are really, ah! I screwed up. Bring it back in. Brandon, he made a comment. He messed up again. These are really useful refreshers on a lot of topics before I start changing cells around. Oh, I assume cells in your tune. Well, good. I'm glad that I can help. That's why I do these. I do these to help. That's why I got the Discord channel. That's why I got the YouTube channel. It's why I do that. I want to help people learn and try and break things down in ways that are easier to understand, so that when you get your aha moment and you get a better idea of how things work in a general sense, then you can zoom in on things and become more of a professional, right? And really become technically savvy. And I was thinking about that today when I was laying in the hospital bed there at my doctor's appointment. I was looking up at the ceiling, thinking about you guys, and thinking about how some learning facilities start at the micro level. Like, this is how a cell works. These are all the individual parts of a cell. These are all blah, blah, blah. Like, just... Yeah, I saw it was reconnecting. So they really in there on the nitty gritty, on the really... That's an effective way of doing it, but it's not the way I think that most learn. I think most men learn big picture and then zoom in to smaller process to components to stuff. At least that's how I learn. And I felt like when I was teaching that my students were really good, or really attained faster rates of progression, retained more knowledge, and understood everything. Because you start off with understanding instead of sticking to like micro and then expanding out until you find like, oh, that's how that works together, right? This is the function of the whole thing. Let's look at the parts of it. And then we go into one part and you go, oh, this is how that works. Oh, that's really neat. Oh, that's why this is, and then you go, oh, that's why the output is affected by this. Whereas if you start way too small, you don't okay, so this, this mitochondria here does what? Like, okay, well, so what's that mean, right? Like, that doesn't really do it for me. If I just went right to the chemistry of a combustion event, and gave you some graphs and said, here you go, that's what happens in there, and you're like, okay, so then what? Wait, what? You know what I mean? So I like to start with the total general understanding, and then dive in deeper and deeper and deeper. And I'm about to connect to my Wi-Fi here in a second, so improvement should happen here in the stream. I apologize if it. So I'm glad that they helped, Brandon, because I'm doing this for you guys. Let's see here. What was that? Trying to boost your ATP. What's ATP? I'm not sure what that ATP is in that case. James says, hey, Dom, looking good, dude. Hey, you know what, James? I appreciate that, but my hair is falling out at a record fucking rate. I was in the shower yesterday, and I looked down, and like I said in the previous stream, it was like worms swimming for the drain. It is falling out at a record rate. I don't know what's going on. So maybe I think I'm gonna be bald by next year. I think I'm gonna be completely bald by next year. Because just a few months ago I was here, and now I'm like this. So it's pretty crazy. Even my hairstyle is like, what is going on over here? I was like, I don't know. It's fucking mass exodus. It's like my scalp became California, and everyone's just getting the fuck out. That's what it seems like. I'm gonna start getting a hat that just says California, the 5 head. Let's see. Need my beanie, right? Yeah, my beanie. Holy fuck! It's 109 degrees right now. 109. On the freeway was 109, and now I'm here at home. It says 105 on the car. I just pulled in, so 105. I think if I had a beanie, yeah, that's only 10,000 miles. I just broke 10,000 miles in this car. I had it for 2 years. I do not drive enough. This Beamer did fucking great, man. I was getting 41 miles per gallon going across Washington on Friday, and then I let the wife drive, and it dropped down to 38. Damn Leadfoots. Fuck, I love her. So that was funny. That was good. I was trying to give her shit about it though too. Every time she gave it a little too much throttle, I'm like, hey, ease off my gas mileage, woman. I'm trying to get a record on this thing. Yeah, this thing rips, dude. I mean, this thing makes like almost 400 wheel, and on my dyno, which is stupid, and it's not my dyno, it's Chase's dyno, and then fucking gets almost 40, gets 40 miles per gallon on a road trip, and then today I've been driving around like crazy, in town, light to light, and some highway. 32 with launch control that blurs your vision. Like, when you hit the launch control on this motherfucker, it's like things get like tunnel vision. And, well, not in this heat. In this heat, you give it throttle, and it like looks at you and is like, get off my back, motherfucker. It bucks you off. But in the good weather, when it's nice outside, fuck, this shit'll blur your vision. And here I'm getting 32 today going through town and everywhere else, and then 40 on road trips. This thing rips. This thing's awesome. But if I drive it like I like to drive it in town only, it might be a little less than that. 14. It might be like 14 or something, I think. I think I usually average like 19 miles per gallon. So this B58, man, the B58's a badass motor. Now this isn't the exact same B58 that's in the Supra, right? But it's the one that's what the Supra one started off as, and they changed the head a little bit, and then piston rods, put a bigger turbo on it. So obviously it's, you know, the B58 and the Supra is better. But this thing is awesome. It's a sweet motor. I don't blame Toyota for a second for choosing to use BMW for the engine and some of the chassis and the transmission, because they use they use ZF typically for the transmissions, and ZF, holy fuck, dude, ZF makes great transmissions. I think I can say with a very high level of accuracy and honesty that ZF probably makes the best transmissions in the world. Aisin makes good boxes, but ZF, man, they make amazing fucking transmissions. And I hate automatics. I hate automatic transmissions, man. I hate driving them. I'm a 3-pedal all day, every day, except for the fact that this thing's a fucking auto. And my 335 was an auto. I bought it because I wanted to, about the 335, you know, a bunch of years ago. No longer with us though. Moment of silence for the 335. I bought it many years ago to learn the N54, right, and tune the N54. And I got an automatic because it's what I could find. It was cheap, and the wife could drive it to work easily. I mean, she can drive a stick, don't get me wrong, but she used to sit in traffic a lot in Cincinnati, so she preferred an auto. I don't blame her at all for that. So I drove that thing with an auto. I was like, holy shit, this auto is amazing. Like, I've always driven behind Fords and Chevy auto tragic slush boxes and Subaru autos. Holy shit, there ain't a worse automatic transmission in the world than the auto that comes in a Subaru. Holy god, I'd rather walk than drive a fucking automatic Subaru. If you have an automatic Subaru, and I'm not sure if I feel bad for you, or if I'm impressed by your resiliency to handle that much suck in your life on a daily basis, because fuck, the Subaru automatic sucks. Man, it sucks. So, anyways, ZF makes badass trannies, and it's got a ZF in it, and it's got the 8-speed, whatever, and the 6-speed and 335 blew me away, and it's the only reason that I've liked automatics at all, and it's only in these transmissions. Everything else still sucks. Drove my stepdad's F-150 with a 10-speed auto. Bleh. I mean, you know, it could be worse, but it's still yuck. And then the GMs that have the 8 or 10s in their SUVs and vans and all that, those things are always shifting. It's like a non-stop shift. They're just horrendous to drive, like the new 2020s or 2018 Suburbans or Tahoes, where the fuck they're called with those things. Man, those things are miserable to drive around. They're just always fucking shifting. They're terrible. They're absolutely just crap. But the ZF, it's awesome. The shifts are crisp when they need to be. They're soft when they don't need to be. It doesn't overshift. It's always in the right gear at the right time. And then I did the ZHP fucking tranny flash on it, you know, to firm some things up, and that made it even better. The ZF is an amazing box. So, anyways, enough of my ZF fucking, you know, nut gargling and stuff, because they make good shit, even though I hate autos. Oh yeah, I gotta answer my ATP thing we're talking about. La 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 la. ATP, basically how your body transfers energy within itself. Just thought I'd throw that in there because you're talking about mitochondria. Oh, gotcha. ATP in that regard. Gotcha. Okay. God, man, it's been so long since I've even talked about that shit. I don't. I'm weak as fuck on that. But I can tell you the side effects of all the medication I take. Yeah, I would definitely. That's one of the things that I wanted to get more into again. I'm always fascinated by systems, right? And our body's a system. And, you know, what we see around us is part of the system, our eyeballs, you know, and our brain, how it interprets all that. And what's really, really crazy to think about, and again, I was in the doctor's office thinking about this as I was waiting for them to fix the fucking telehealth machine, was that our eyes only see certain spectrums. There's other stuff that's there that we can't see. How much? Right? I mean, there's waves. There's electromagnetic waves and, you know, all sorts of different kind of radiation and that kind of stuff. But there is other stuff I mean, there's air in there, right? You can't see the air, right? There's small things. There's less dense things. There's things that are high density as far as, you know, concentration per area that's still invisible to us, right? And it's really crazy to think about what we see and what we put so much weight on, right? How much importance we give to the things that we see. How that's just a fraction of what's actually there. So from me to that fridge, like, there is a bunch of shit between me and that fridge, but I don't see anything. And that's one of the things that I always tell people when they make some grandiose assumptions. I tell them all the time, just because you don't see it doesn't mean it didn't happen. Just because you don't see it doesn't mean it ain't there. You know, like, there's shit there. And who knows, on a spiritual level or on an extraterrestrial level, if there's stuff in different dimensions and different layers of perception, if there's shit walking right by us and we don't even know, like, because it's just our eyeballs, man. Our ears only hear a certain range of frequencies. Our eyeballs only see a certain range of light. You know, our touch is only good for heat and slight pressure changes and, you know, that kind of stuff. Like, how much shit is actually there that we don't see? And it's kind of crazy to think about. But aside from that, back to what I was starting with this thing real quick. I want to recap it because a bunch of people showed up after I got to talking, and this is a live stream, so that means you missed it. And so what I wanted to talk about was manifold pressure not being equal to what's in the cylinder, right? On the intake stroke, the end intake stroke, if you have 20 pounds of boost in the manifold, you don't have 20 pounds of boost in the intake, or in the cylinder. Often, you don't have 20 pounds of boost in there. And the smaller the cam, the less you have in there. So that's one of the things that people miss out on a lot when they compare engines and they say, oh, well, you know, on 20 pounds of boost, I made this much power. And then this guy made more at the same boost. I heard some guy say boost is just boost, man. Well, if you have 20 pounds of boost, it's the exact same amount of air. And that also isn't true. Because valve overlap and a bunch of other shit that we can talk about for hours and stuff. So I just wanted to clarify to people that if you're trying to figure out how much air is getting into the engine, without an accurate mass airflow sensor, you can't calculate that. Because manifold pressure has only a fraction to do with it. The cam size will dictate how much of that gets in there, whether most of it gets in there or only a little bit gets in there. And then there's all sorts of stuff with resonance and overlap and valve timing. If you think about the engine, if I turn the engine really slow, and I have a cam that shuts at bottom dead center, and it's like 1 RPM, then you can pretty much guarantee that at 1 RPM, I have 100% of the volume of that engine is fresh air charged, provided, again, there was no exhaust overlap, and the valve shut at bottom dead center, and the engine was turning slow enough that the air had enough time to fill the cylinder from the intake manifold. Okay, that's great. But now let's put a real cam in it. Real cams close 35 to 65 degrees after bottom dead center. So if I turn that engine really slow, as that piston moves back up again, and then I shut the valve, I've pushed air back out of it. Or, if the piston's moving really fast, right, now the piston gets bottom dead center, and the air is still coming in there. Now, why is it still coming in? It's coming in because I've drawn a vacuum on the back side of the valve, right? If I suck on an orifice really fast, right, there will be a vacuum on the back side of the valve. So even though the piston starts moving its way back up again, and I get 30 degrees up or whatever, air is still coming in because that vacuum has not yet turned into a positive pressure for the piston to come back up again, right? So there's almost always a vacuum on the back of the valve until we start getting to really high boost numbers. But even then, we're talking about a lower pressure on the intake, on the engine side of the valve versus the manifold pressure. So trying to establish a mass of air in the engine from the manifold pressure and temperature alone, you can't do it. You just can't. And you can't do it with TMAP because that's ideal, right? If I have this throttle and they say this much air goes across it, air goes through it, well, that's an ideal situation. I can hold it open, and I have now. You can use at partial throttles. You can use that more accurately because you can use a differential pressure across, and knowing that different flows will result in different pressure across it. You can use that, and that will have some accuracy. But when you get to full open, there's no more accuracy there. You can have like a tiny bit. I mean, there's some accuracy, I would say, right? Because the overall throttle size still affects the flow through that region, but you're losing accuracy because now you're getting really deep into flow dynamics through it and into the manifold and from the pipe. You know, the resonance of the manifold may change the way it goes, the laminar flow nature through the throttle body when it's full open to the inner from the intercooler pipe correctly, like all kinds of shit that would just totally screwed up. And so the only way you could really know is what I said earlier in the stream, is you have to know exactly how much fuel went into the cylinder, and you have to know exactly the fuel density at the time it went into the cylinder. And then you would have to know a precise air-fuel ratio at the end. And what I discussed earlier too was that that's affected by overlap. It's affected by pressure in the manifold where the O2 sensor is located, pre or post turbo, either way, it's still affected by pressure. And it's affected by overlap in that you could have air get into the exhaust during overlap if your cam timing is such and your manifold pressure is high enough. In some cases, you're pushing the extra air into the exhaust. And in some cases, you're not. In some cases, the exhaust is going back in the intake manifold because a lot of overlap, really high exhaust back pressure and things like that. So in an NA situation or a low boost situation where the exhaust pressure is lower than intake pressure, then you can technically get some flow through the engine, through the valves during overlap and put some fresh air charge, oxygen, and sometimes even fuel too, into the exhaust and have it burn in the exhaust. And that will disrupt your air-fuel ratio's accuracy, which induces more air, right? So you can't know accurately what the actual mass airflow through the engine is without having an actual mass airflow sensor that's properly calibrated. Everything else is an estimation. And that kind of, bounces back to what I said before about speed density. Speed density is an estimation. It's always an estimation. It always has been. And mass airflow is a measurement. And so there are going to be inherent inaccuracies. But certain engine management systems like to give you the illusion of accuracy, the illusion of control, and the illusion of data by telling you, oh, well, you had 200 and something grams per second of air going in the engine. And without a mass airflow sensor, that ain't right. It could potentially be right. Like they could get it right on accident, but it isn't an accurate calculation based on the data they have because they can't have that data. You can't. Unless you have something telling the specific gravity of your fuel at that instant, unless you know that your O2 sensor reading is accurate, overlap's not fucking it up, pressure's not fucking it up, the pressure waves in the exhaust aren't messing it up, because they will, then you don't know. And so you're going to have some error. So don't bank on that kind of stuff. You can get in the ballpark, you can get within probably 10%, that kind of thing, and you can get in there and be happy and utilize that to monitor changes, right? If you do a modification and like, oh look, I'm showing a gain in airflow, then yeah, absolutely use it for that, right? But the baseline isn't correct, so don't make the change or the baseline an absolute. Use it as a reference point. It's like a dyno, right? If I put a car in the dyno and it makes 230 wheel horsepower, does that mean the engine made 300? Or does it mean the engine made 320? Well, you don't know. You don't know because you don't know the drivetrain losses of that machine or of that automobile. You don't know what kind of friction losses are in the bearings of the machine. You don't know a lot of stuff. And so to absolutely state that, oh, this car is making 600 at the flywheel for certain because it made X at the wheels, you can't, right? You cannot make that assumption. You can get close. It's around this much. Yeah, you can get that. It's around that, right? And so what's the dyno good for if you can't do that? Well, it ain't good for that. It's good for changes, right? It's good for getting a measurement at one point, changing something, and then getting a new measurement and saying, hey, look at that. I got a gain of about 24 horse. Now, is that accurate? Not always. The temperature, the humidity, the pressure, all of that changes from day to day and even during the day. So even then you have some error in your dyno reading. You're going to have it. Air pressure in the tires, you're going to change the reading. Change wheels and tires, that test is now null and void because wheels and tires change the reading of the dyno significantly, right? Change your oil, change your training fluid. You have a U-joint starting to go out. You don't realize it yet. All those things are going to change your alignment, turn heat into to sliding rubber, right? Like you're gonna have slight intricate differences. You strap it down really aggressively one day and not as aggressively the next, and you're not binding part of something. Like all that stuff will affect the reading. So even then, like the machine can't give you 100% certainty what the gains are. And unfortunately, a lot of people and even tuners really want it to, right? We really want it to. We want it to either confirm our bias or give us some data that we can use, whether it's good or bad, and we put too much value in it. And in the end, it really boils down to, are you having a good time with the car, or are you getting the results that you want on the track? Because dyno numbers don't fucking matter, right? Dyno numbers do not matter. They don't fucking matter. So what? Oh, my car gets 1,000. Good for you. But what are you doing with it? Oh, I just drive around and park in front of people so they can stare at it. Like, well, technically it can make 0, right? Or maybe 5. You have to get it off the trailer or not. Like, it doesn't fucking matter, right? And what matters is, are you enjoying the car? Is it doing the 9s in the quarter mile at 450 wheel? Or is it doing 12s in the quarter mile at 450 wheel? And you're like, is that the power I need? Is that dyno accurate? Probably not. Probably not. If it's a US made dyno, the answer is no, it's not accurate. Plain and simple. US dynos are overinflated. I've learned that over the years. So, in the end, do you love the car? Do you love the way it drives? Does it feel great? Did it beat that of the guy at the stoplight that you wanted to beat? Does it do the track time you want? If it does, excellent. The fucking number doesn't matter. Doesn't matter. I should rename the stream to Tangent Day, right? Because you get off track. I talk about stuff you can't see, learning techniques, and then dyno accuracy, and then what's next? The meaning of life? I don't know. What is the meaning of life? No, I'm just kidding. I would never do that. Never do that to you. Oh shit, here we go. FAWX update. Saw it in the background. Any FA? I have no idea what you're talking about, James. What FAWX? For eat is for yeet. I mean, for throwing away yeet? Yes, absolutely. At least you can choose 1, 2, or 3. It's a manual, bro. Hi, Jim. Welcome. Missed your rant. ZF good? My ass nasty. Yeah, ZF's awesome, dude. Only auto Dom approves of, so it's good, yes. Drink enough Monster, I can see noise. That's the same with mushrooms and LSD from what I hear. New David Attenborough short series Netflix actually hits that a bit. They use a nice filter to illustrate the difference animals can see. Oh, the different, yeah, for sure, right? VA. Yeah, I don't know what VAWX you're talking about either. You remember the STI, the white STI? Is that what we're talking about? Because it ain't an FA. And it's not WX, it's an STI. Motherfucker. Yeah, so, oh, the red one? Oh, mine. Oh, hiccups. Mine, right. Yeah, I'm stupid. I forget I have it sometimes. Yeah, nothing's gonna happen. I have 11 cars, dude. I have 11 fucking cars. So, my friend Dave actually called me yesterday. He says, "Hey, dude, you have a lot of cars." I'm like, "Oh yeah, I've heard that before. Thanks. You know, how original." He's like, "Can I borrow one?" Okay. Yeah, I'll let him borrow one. So, thought that was funny. Oh, check this out. These are my LS Rockers Shims. So when you're in between push rod size, especially if you have like mechanical mechanical lifters, and the proper preload on those, on many of those is 0. But you can't get them, in between sizes, right? Sometimes even the size they claim they make, they don't have in stock, they won't have it for like a year, so it doesn't work out. So shimming the rockers a smidge helps. Also, there is some geometry issues associated with the rocker placement on these, and shimming the rocker a smidge can help improve the geometry. Also, some valves by manufacturers are made longer, and shimming these helps improve that. Or if you're running other LS, what is it? LSA valves, LS7 valve. One of the valves are longer than the others, and you put them in another head, then again you have geometry issues, and so you can use these to fix that geometry issue. So that's pretty cool. So, isn't that a shim? A carriage guide rail. I don't know what carriage guide rail you're talking about, but this is for the rockers. You'll see that the bolts are in the correct location for the rockers on an LS 1 through 1, 2, 6, and a bunch of others. 4 LQs, LM7s, all the cathedral ports basically. These are good for. I don't know if they were for LS3 or not. I gotta double check if the bolt holes are the same for that. I know that the rockers are offset and funny shaped in the LS3, but I don't know if the bolt holes are the same or not. If they are, fucking sweet. I got them for more stuff. But I got a 17 and a 30. I forget what I ordered. Is a side profile geometry unique for the application? Yes. Yeah, each hole is strategically placed to allow a rocker bolt to go through it. Hello, I can see you. So that's those are space you see close, far, that's for each cylinder. Looks like a guitar. Oh yeah, this is a dozen of them. So I have 2 dozen total shims. I have 12 in each size, which is enough for 12 cars, unless I need more than 1 shim for 1 car. And I did it with 2 close but slightly different or different thicknesses, so that you can mix and match and get, you know, other stuff. Yeah. Anyways, I'm happy. I think it's 20. No, it's 20 something and 17 or some shit like that is what I got. So I can still get little steps out of it and add them up. Oh, my dry sump. I want to tell you that too. That's almost done. My crank pulley. Ooh, I'll show you that. I feel like a kid. Yesterday, I got some boxes, and in one of those boxes was a new gun, well, parts for the gun. So that's really cool. And then the dry sump pulley or crank pulley. Now, I didn't open the gun until like 1 o'clock this morning because I was fucking around with this stuff. So this is a 3D printing of some Hewlett Packard flow jet something. It's actually really cool. It's pretty dense. It feels pretty good. And the accuracy is really impressive. I mean, let's see if I can get it on the camera. How close can I get it? That's pretty blurry. But it's really, really good. I don't see any evidence of there being any fill material anywhere, any supports, right? Like, this thing did really good. So I opened it up, and I immediately go, that's not big enough. What the fuck? Like, I know what I set that bigger than that. There's no way the crank on the Subaru is that small. And if you look, you see that black ring? Yeah, that's where the crank actually is. So that's how big it is. That little black ring, the tiny little mark, that's what the crankshaft actually is diameter. So if anyone ever tells you that my micrometer is not well calibrated, they fucking wrong, because I was right. Just that little thickness was the difference in where this thing, laser sensor nylon. I don't know if it's that. It was a Hewlett Packard thing. But yeah, so my micrometer is definitely calibrated because I noticed immediately that was a few thou off. And you can see, like I said, it is a few thou off. It's supposed to be 24 millimeters, and this was 23.5 or 6, something like that. Like, it was a little bit, but it was enough. I was like, that ain't big enough. That hole's not big enough. And it did not fit on. Did not fit. Now, however, with some fuckery, I was able to check some other things, and I found out I did goof up. And I somehow made it an overdriven pulley. I made it a larger diameter than the factory one was. That was one of the things. Other one is the hub, this diameter here. I don't know how I got the wrong number in there, but the wrong number was in there. And that hub was too big. Which sucks because it's got to fit in the plastic cover, right? That goes over the oil pump and everything. And this hub was too big when it go in the hole. Shitty. But what was really good news about that, yeah, the timing cover, it wouldn't even go in. Now, what was really good news about that is, see this, how thin that is? The back end of the tooth, right? Like, there's a groove in there, right? And it's, I mean, it's going to be aluminum, so it's not going to be weak, right? But I like stuff to be sturdy. And I was concerned that this, because like I said, there's overhang in there. I said overhang. I was concerned that this would not be strong enough with some hard miles and stuff on it. Well, since I got this diameter wrong, I got to shrink that down. I can move this down. Now the final design is nice and thick under there. It's going to be plenty strong. So I'm excited about that. Also, I did some more testing, and I have more room in this direction, so I can run a wider belt. This is only set for a 15 mil belt, which seems pretty narrow when you see most oil pumps have a 30 mil belt on them. However, most of those oil pump people are running the old HTD belts. HTD? I think it's called HTD belt. Where the new belts with the exact same pitch on them have 2 to 4 times the strength of the old HTDs. So technically, I could run a smaller, skinnier belt. Now, that is really advantageous because as it is, the Subaru up front has issues with fitment. And if I stick, say somebody's like, I don't want to give up my fluid damper, and I don't blame them. Fluid damper is a good fucking pulley. If you don't give your fluid damper up for my solid aluminum piece, I get it. So if I have to make a hub that goes on the front of a pulley, it's better to make one that's 15 millimeters than it is to have to make one that's 30 because radiator fans and other shit are in the fucking way. They're just in the way. So it was good news that I had room to make this wider, so I knew it was going to be stronger, and then also that I can make it so we can use thicker and thinner belts as needed for whatever. So I got to make that stronger. It changed that. It did make it 0.07 pounds lighter. 0.07. Damn it. What am I going to do? I had to throw the whole project away. Give up. Next project. Extra 15 millimeters sound like it'd make it impossible. Yeah. So you would not get another 15 millimeters between here. I mean, that would be the end of the hub, right? So you'd have to like remove the whole center timing cover, which some people would do. You know, they'd be willing to do that. And I considered making a cover. So like, you cut out a section, you take mine, you put a template on there, you cut out your timing cover because the belt goes one path, and then you put my insert on there that covers it and gives you like the clearance in an area. But you only have a little bit of space. Right? There's only so much space before you start interfering with the timing belt. So that could become an issue. Now, the timing belt starts a few millimeters behind the end of this hub, right? Because on this side of this hub is the timing gear, right? The actual gear on the front of the crankshaft. And that timing belt's a few millimeters from the back of that. So even if this was, 15 mils longer and it went to here, there still would not be belt interference, but there would be this belt, the timing cover interference. And so some sort of thing would need to happen. And so it made more sense just to sell this with the right belt, the stronger GT4 belt, which is like 3 or 4 times stronger than the original HGD belt, and use the narrower one. So for guys that have the daily kit, you're going to get this, a new pulley for the pump itself, and the matching bolt, and maybe even a tensioner. Since it's the pulley guys out, the daily guys won't use a tensioner, I don't think, but my kit can use the AC tensioner bracket to have a tensioner installed. So somebody wanted just a slightly spring-loaded tensioner on there to keep some of the flap out, and that kind of stuff, then I'm going to do that. So that'd be pretty cool. If you haven't seen the dry sump yet, it is looking really sweet. It's also looking really expensive, and so I finalized it and then unfinalized it because I spent quite a few hours trying to simplify certain parts of the pump. There are certain operations you do that add a level of complexity and quickly increase the cost of each individual part. That's part of manufacturing. When you're designing something, bean counters are always involved. And in the case, I'm also the bean counter and the engineer because it's just my business, right? And my wife gets to help me do a little bean counting too. So I have to, in the market, right? The market only yields so much. So I need to make a part that can sell. I need to make a part that fits a need in the market, and it needs to be cost effective. So I went through and said, okay, well, what can I do to this pump now that I designed the sweetest pump ever fucking made? Now that I designed this really awesome pump, what do I got to do to make it also affordable and profitable, right? I'm like, if I'm going to make $5 per unit, I'm not going to sell it because it's a dry sump. I'm only going to sell, fucking maybe 10 units a year or something like that, right? So it's got to be worth the time, and I've already spent a couple weeks, designing it. So, oh good, my fucking hose is finally on the way. Let me show you. This is Solidworks. Okay, so the new pulley, you'll see, much thicker right there than the other one. Instead of being so thin, much larger cross section here because this is smaller. I made more room for this. I could bring this down and all of that. So that worked out well. I had to go in and adjust these. This right here was too tight. It was like an 8 thou radius. It came down a lot deeper, which is very, very difficult to get a tool into. And it's not impossible, but what happens is it becomes very, very expensive. So by increasing this radius, as it is, the belt ends right here anyways, right? So by increasing this radius, not so much that I lose any air gap. You may not know that. The air gap between the belt and the pulley at the bottom is useful for cooling. It helps keep the belt cool and keep it from wearing out prematurely. So by having that, then I gain some cost effectiveness. The pulley costs less to make. The same goes for this profile. What you'll notice is the HTD was a full round and this was the pocket. But the GT4, they flattened off the bottom of the tooth. And flattening off the bottom of the tooth, you go, oh, there's less engagement. That's not as good. That's not true. That flattening of the tooth provided an air volume between the belt and the pulley again. And that air volume cooled the belts and increased the horsepower rating of each belt because it now could handle the heat load. In addition to more strands of, high-tech nylon and steel and whatever else they fucking put in there and the surface treatment and all of that, keeping it cool is important, and so adding the air gap is good. So what you'll see is that the belt calls for this profile, but the belt itself is flat on the bottom of the tooth, and so it's for cooling. Little bit. Also, if you get something in there, whoops, I'm fucking this weird to do through the phone. If you were to get something on this and then some built up of dirt happened, that belt came by and it was full round, you would separate the belt from the pulley, and you could potentially lose some grip or throw the belt off. So having the air gap there also increases reliability because now we're no longer dealing with that shit. So okay, so that's that. Let's get to the dry sump real quick. Let me show you where I'm at right now. This assembly is becoming gigantic. Now, I don't know if you do assemblies in SolidWorks before, if you've ever done that. The bigger the assembly, the more of a nightmare it is. So you'll see here, I had this bolt floating in space. I was working on this last night to change this bolt length to minimize some of these overhangs that I had machined in here. And so I found this bolt. I got the CAD drawing. McMaster-Carr is fucking awesome because they provide you CAD drawings of their shit. So this is a piece right here. This parting line you'll see here, this is actually a whole nother piece. And so this overhangs, and that actually is done a little bit on purpose so that this piece here can index inside there and control rotation. It also indexes into the lower bearing slot to provide the preload on the bearing to hold it in place. So it has one index there, and then these here just provide more control on this rotational plane, right? But I don't need to have them there if I use a shorter bolt. It's nice. Now the bearing itself is in this piece right here. This piece has the bearing. That's also why I have the mounts on here. The mounts are attached to the bearing housing, since all the load is being distributed from the shaft to the bearing. It should go from the bearing to the support to the mounts, not from the bearing to another piece with supports, right? This makes sense. So the mounts are here. The attachment from the front to rear are all on this forward piece. These mounting bosses here, this generic 3-bolt bosses, just 3 attachment points that are available. That all is to the main bearing surround or support. And then over here, this is the rear bearing support with the attachments as well, just a boss. Now you'll say, wait a second, this one's only got 2 and that one has got 3. Well, there's a port in here because this is the suction side of the scavenge chamber that I have feeding or pulling oil out of the bearings, because you don't want the bearings to get completely flooded with oil and all of that, because that creates a lot of drag. You want them to get some oil. And so on the suction side of this scavenging chamber, there's a hole that goes into the bearing chamber to minimize the amount of oil that collects in that bearing. Minimize drag and keep more horsepower free. This rear cap, actually, before, these screws were inside a little bit. There was an O-ring on the outside, which meant I then had to have O-rings in these screws. Well, that doesn't fucking work, right? That becomes expensive. So I went to a smaller O-ring to seal it inside, and then these went outside the O-ring radius. Let's see if I change the... I can't see it through my phone screen. Here we go. If I change that, you'll see there. That's the O-ring right here, and those are the bearings. So that's one that seals this system, and you see now those screws are outside that sealing surface. So I don't have to have O-rings on each individual bolt that holds this cap on. Now I have a lot of on here because even though I already have mounts here, I still need something in this plane. So I'm going to end up sticking bosses on this end cap and the front end cap. So yeah, good luck with that. Wait till you see the internals. So that you can attach to the back as well. And I also have another end cap made for guys that need to run the hex drive for mechanical fuel pumps. And I have the shaft. This shaft comes in another, I go to hex drive fuel pump, another configuration. I forgot to hit that button. Bam, now it's got the hex drive in the back, so I can change the cap and the shaft to meet up the demands of the guys that want the rear-driven mechanical or rear mechanical-driven fuel pump. So that's another configuration change or option that that you can do. All right, let's make this no longer invisible. Oops, that wasn't the right spot. Okay, so this bolt, when it comes to machining, the best way to save money is to use stuff that exists, right? So I am using bolts that exist. I'm using seals that exist. This is an actual SKF seal. You go to SKF's website with the part number that you want. You go through the whole catalog, choose what you want. This is it's a seal made to handle pressure, like 80 pounds differential, which this should not see that kind of pressure. It has an auxiliary lip on the front to minimize dirt intrusion, but the actual sealing lip's on the back side, so that pressure pushes the lip down and seals the lip, and it's got non-slip outer coating, blah, all this stuff, right, for this seal. It's made of special material, it's fuel and oil resistant, etc., etc., etc. But when you finally go through the catalog and all fucking 580 pages of whatever it is, when you finally find the seal that you want, if you put the number in on the website, they provide you the option to download CAD drawings in SolidWorks and AutoCAD and that kind of stuff. So I downloaded the CAD drawing of this seal and dropped it right in my model. And then I can verify fitment, I can change things as needed, right? They also give you the shaft size and the outer dimensional of what the bore needs to be for the seal to fit snugly and not come out and to handle the pressure that you're going to give it and all of that. So they give you those dimensions as well. So you got to use that dimension when making this hole, this bore here. This is a different screw. This is a different screw. This is only a 1032, the one that was in here right now. Is that the big one or the small one? That's the big one, the new one. This one here, 1032. Not a big diameter. It's only 0.19 inches. Not a very large bolt holding this together. Now, realistically, this thing is not trying to blow itself apart in this direction a whole lot. So it shouldn't take much force. But I just didn't feel good about having something small like a 1032 that was 6 inches long in here. So I found some stainless M8. I think they're M8s. Let me double check. This was late last night at 3 in the morning. I go evaluate, measure that. Why is that? Delete that. There we go. Area, perimeter, diameter, 0.24. So is that M6? So it's an M6. Still not gigantic, but bigger than a 1032. And like I said, you don't need a lot to hold this together. It's only 6 inches long in the first place. It's not trying to blow itself apart. And it's indexed at every one of these slots right here. This is actually a plate in the middle with a chamfer. And these pieces fit snugly into this chamfer, and they're located on multiple planes at once. You see I got angles here, right here, and here. So that holds the center sections in, because it's important that these sections are correct, because the clearance between them and the internals, let's see if this works, is pretty small. So this is showing interference right now because it's not timed. I haven't timed it correctly. So if you go to like the outer hub, right, there's not a whole lot of room in there. Let's see if I can get a better picture. There's only a few thou in there. Now I may find that in practice of testing, I got to make that a larger clearance. You know, who knows? And then also the other direction, this way, I only have between 3 and 5 thousandths between the rotor and the end plates. So it's important that these things stay in alignment. Otherwise, contact occurs, and contact is bad. So look at this in the bearings. Even the freaking balls are modeled in the bearings. Again, from SKF. You get this thing from SKF. You can look at the balls, look at the seals, the shields. Everything is in here. It's really, really sweet. Anyways, and like right here, there's all the balls. SKF gives you all that data. It's pretty sweet what they give you. Anyway, so it's really damn close. This is weird. A slight delay on the phone and all this stuff in the different angle. So it's really close. I'm almost done. I just have to finish doing the bolt holes on the front. Right here to hold this cap down. I already moved the seal in last night. So, and I have the threads actually in here already. So now I got to carry these out to the cover plate. And then I will adjust these lengths, put these different length bolts in to minimize the overhang or reduce the overhang, to still give me an index, but not too much, and reduce costs, because that would make this whole piece thinner, which means less material. Less material means lower price. So just a few things like that. Knocking 100 thou off of this reduces the material need to make this part, reduces the price need to make this part. So little things like that go a long ways in your design, especially when you have multiple, for the length of the part and that kind of thing. So, yeah, so that's what I'm doing here. Almost done. I got gears for the pressure stage. Oh, that's one thing I also was considering doing, was moving this pressure stage to second and the scavenge to the first. Not many people do that, but my philosophy is I don't want to have too much of this high pressure pushing its way into the bearing section and the seal section. If I put the scavenge chamber between the two of them, than the bearings in the middle. Also, than the high pressure in the middle. Also, I used this gear for timing the rotors. Other companies that have the aluminum, root style blower rotors in their pump, they add on a special timing gear that bolts on the end of them that times them to each other. And that's fine and dandy, but that's more parts. Well, I already have a timing gear in here. This guy right there, the main pressure stage of the pump, is already got the same 25-degree pressure angle and teeth that you would have on a timing gear. It is literally a timing gear in this pump. So I have the lobes or the keyways of these gears and the keyways of the 3 lobes synced in such a way that these oil pump gears provide the timing for the roots blower slash evac chamber. Now you can see here these are in the same direction, which is not correct. It's off by 1 tooth, I think, and that's why my rotors are off right now. Let's see. Oh, they're off a lot more than that. Yeah, they're off a lot. So the way you fix that, though, I don't know if you ever use Solidworks or not. Solidworks is pretty neat. It's also maddening and can really piss you off. They have these things called mates. That's how you get things to react appropriately with each other. You can turn them on and off. Let's put this back in time. Let me zoom in. Get it pretty close. There we go. I got some clearance on both sides. Then I can re-enable the mate again. Where'd it go? There we go. Unsuppress. And there we go. Now it's back in time. It turns, and if I go further with this, you will see now that the lobes of the blower scab sections are also now in time. Now, I spent a few hours making this profile. It's actually really sweet. I'm really proud of it because if you look, it's got almost perfect contact through the entire rotation, and never at any point in time do I trap a volume of fluid. I spent a lot of time figuring out what the correct ellipses would be for this, but there's no trapped fluid in there, and so there's no required leakage or bypass needed like there is on a gear. Gears need bypasses because you end up trapping a volume that gets squished and then blows out the sides, and you lose a lot of power that way, or you can create heat or aeration and all kinds of problems with your oil. But you can see here these lobes are freaking perfect. It took me, like I said, a couple hours to get the ellipses just right for what I wanted, but it came out really good. Very, very happy, very proud of that. And that's the way it would turn. And that right there. So if you're looking at this, which side is the pressure, which side is the discharge? This throws everybody off. And I totally get why, but almost everyone gets this wrong. So in the chat, is left suction or discharge? The left side of my screen. I'm going to turn this direction right now. Is left suction or discharge? No guesses yet, huh? I don't know if I have fluid mechanics turned on this, Travis, but you can calculate a bit of that yourself. The left side is suction, that's correct. The right side is discharge. Because the volume is trapped on the outside of the rotors, right? So it comes in, boom, I trapped the volume in here. Now this is trapped in the lobes. I take that volume and I move it over to the side of the pump, right? And then I squish it out as it comes into contact. And then this gets smaller. And then I take another volume and I add it to it again. So yeah, this is the suction side, you're correct. So what I do, Travis, because I don't know if the fluid flow thing can do that or not, is I calculate the amount of volume that this traps every revolution, right? How much volume does this trap per revolution, right? I have this volume that goes from here, like that, is trapped, and then it gets blown out, right? So what is that volume amount? So I calculate that for both rotors every revolution, and then I knock a good 10 to 15% off of that to compensate for leakage and weirdnesses in what happens right here, right? I mean, you see here this volume gets larger as it opens up, but then it kind of starts to get smaller for a second. So they try and compensate for some of that. And then, of course, leakage by the gears, leakage between the gears, leakage between the gears and the housing. But I went with the 3-rotor instead of a 2-rotor for this main reason here. If I want to have a high pressure ratio between the two of these, right? If I want to have a lot of suction pressure in relation to the discharge, then, and there's no perfect seal, right? Because there's a gap in between these. So each of these is an orifice, much like I talked about earlier with the whole valve being an orifice to feed the cylinder. That's an orifice. And it takes time for pressure to equalize and through here between the two of them. Now, if I have 2 steps, like I have here, then the drop to this one will be less. I'll have less pressure drop per rotor, which means I've restricted the flow backwards through it by adding 2 tortuous paths. I mean, that tortuous, it's just narrow, but, you know, labyrinth seal, we call it tortuous, that's like change directions a bunch and all that. But this is just, you know, through this tiny little spot in here. But now I have 2 pressure drops. Instead of, this was a single rotor, having just 1 that came around, then having none, and then having 1, right? So I always have 2 pressure drops across this part of it. And then, unfortunately, there's only 1 contact point in the middle, but there's only ever 1 contact point in the middle, unless you get into multi teeth, like the gears in the end of this thing. These, I still don't think they have much more than 1. I think like 1.5 tooths. All right, 2 points of contact. Here we go. Almost 3. It almost makes. Oh, it's pretty close. That could count as 3 technically, but I think it opens up when I turn it up. So I gotta shiza. I gotta hit OK. Wait forever. There we go. And then I go here. 1, 2. I got 3 there. 1, 2, 3. Oh, I guess I always have 3 points right here. That's not bad. So I have 3 points of contact on this gear, which is going to be one reason why these things also can do so much pressure. That you have all these little chambers, you have lots of contact on outer here, right? So there's fewer paths for leakage, and there's more points of contact to minimize leakage. And then also many teeth in here as they're flowing along creates a smoother pressure than the scavenge chamber. Because every rotation of the scavenge, you get 3 pulses, 1, 2, 3. This one, you get 11 pulses. So it's a smoother discharge in relation to other gears. More teeth would be the smoother discharge pressure. Anyways, so that is my CAD lesson, I guess, about how to make a dry sump. But we're almost done. Almost done. Where'd my seal plate go? Right there. I just gotta finish the holes, change these, move this over, put those bolts in it, and then I'm ready to send to the machinist and have him laugh at me tremendously and tell me that there's no fucking way I could build these for less than $5,000 each. And then I will tuck my tail between my legs, come home and cry for a while, and then figure out something else. No, it shouldn't be too bad, because even while this looks like there's a lot of shit on it, a lot of these are repeats. This is the same stage as this, same stage as this. This is just configured without a hole in it. And then these plates are all the same, with the exception of this one here. This one is a plate that's open in the middle to allow you to use both discharges together. So, you know, really, it's got 6 pieces, or 1, 2, oh, more than that, huh? Just 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 main pieces. Only 5 of them are unique, because there's repeats. This one, this one, this one, this one, all the same. This one and this one are the same, right? See what I'm saying? So having a lot of repeat pieces reduces cost, because that means there's less total different parts needed for the assembly. The O-rings, I have O-rings between every one of these, and what I did, I made sure that I could use the same O-ring on almost every point. So, I hate you, Solidworks, and you do that to me. It gets all weird. It won't let me cut this direction. It says I'm making invalid bodies, which doesn't make any fucking sense, because it's just a section view. Like, I'm just trying to look at the inside. It's like, oh, you can't do that. You make some things not work. I'm like, what? How's that work? I don't know. So, like, these points here. I forgot one. I gotta do one more. Yeah, I gotta do one more O-ring. Huh? Look at that. Okay, so all these use the same O-ring. And then on both ends, this one over here and this one over here use the same O-ring. So they're the same O-rings on here and then these all use the same O-ring in the middle. So there's only 2 different O-rings on this whole thing, even though there's a bunch of them. So one of the keys is using existing stuff, not needing custom stuff, and then making it work as much as possible. The keyways are just shelf purchase keyways. I already got some. I bought. They're in a little box over here. Just a little square stock. You just lop it off the size you need, drop it in the shaft. Let's see if I do it. If I just click this. Where'd he go? There it is. So like here's the main shaft with the hex for the fuel pump drive. And then there's the keyways. See a longer keyway on the pressure stage. The pressure stage gear isn't this full length. The hub of it, I put a hub on the end of it. And the reason I add the hub to it was to increase the strength, because all the power is going to be transferred in this one keyway. This one keyway has to drive all the gears, right? All of them. So I added a lot of strength to it with a bigger hub and a longer keyway, so that I could hopefully, fingers crossed, hopefully this is strong enough to drive it. I mean, a single keyway is typically strong enough on like a crank pulley on a blower. However, they're also bolted to the shaft, and this is not bolted. This is slid on, and there's spacers in there, and then it's just between a bearing and a clip. There's no preload on this shaft that holds everything together, and that might prove to be an error. You know, that could prove to be an error, and that's why the first one is a test. You know, will get abused, and I may find that what I need to do is thread this shaft and put a nut on it. Let's see. What is the ratio of engine RPM to pump rotor RPM? So I made my pressure section a little small so that I could slightly overdrive it. So a 40 tooth on both ends down to a 37 potentially on the pump to get the RPM it needs, but it's really close to the same to slightly overdriven. The new belts are stronger and can handle more RPM. The bearings in this are fucking amazing bearings. They're way over for this, but they're like ceramic ball, low friction, you know, badass bearings that go in here. So I'll be able to do plenty. It'll handle lots of load. And also, a lot of guys use just bushings on the lower shaft. It lowers the cost. It does lower, it can lower some of the power drawn by the pump to use bushings on the lower shaft. But since I'm using the lower shaft to drive the other rotors through the timing gear, which is also the oil pump gear, then I want to make sure that those bearings are strong, because they're going to handle load, right? It's going to try and push the teeth away from each other. That's what the gears do. They try and separate the shafts. And so that's the main area that handles all the load. And so I want to make sure that it was plenty strong. But like I said, I may end up having to put a threaded end on this and gronking the gears together tightly to squish them together, to add more load to it, to minimize any sloppiness that happens. Now, the ones on the rotors, they don't actually touch each other. So all the load, only they're going to experience is oil and air load, and that's it. Whereas these touch each other, act as the timing for everything else, and drive the force between all of them. So these gears have definitely a lot more work on their plate to handle, so I added extra hub strength to that. And if I thought I could get away with another keyway, I would. Actually, I might. I probably could get away with another keyway to help out on those gears. Yeah, I could. So I might do that. Just add 2 keyways to the shaft on this gear to ensure I have more surface area to transmit the forces that it's going to see, so it doesn't strip out on us. So that'd be easy to do. I just take this guy, mirror it to the side. It's actually pretty easy. I go back to main shaft, go like this. I can just use the top plane, which is dead center. And then I can hit the pulley keyway right here, which I labeled pulley keyway. And then go to features, hit mirror. Where the hell did the mirror go? There it is, mirror this feature on the top plane, like that. Hit go. And do. Where'd you go? Oh, wrong pulley keyway. Haha, I'm funny. So it wasn't pulley keyway. It was stupid. Front keyway. That's the one I wanted. Mirror that on the top plane. And actually, pulley wouldn't be a bad idea either. But the pulley is going to have a clamp on it as well. It's going to have something that squishes it. But there we go. Now you see that one's square because I forgot to mirror the chamfers in it, which is easy to do. I just right click on it, hit edit feature, and then I can add my fillet. Is it the right one? Oh, I did the same thing on all of them. Well, that's not going to work. So I'll have to do it myself. No big deal. I did all the fillets together as one operation, which is probably a mistake. I should have done only the one so that it copied over. No big deal. I throw a fill on that. Boom, it's done. I have 2 keyways. We're good to go. Let's close that. I'm not going to save changes yet. All right. The only thing I don't like is that even with the shorter bolt and that slid down, there's still exposed threads. It's the only thing I don't like. But I don't want to make a sleeve because that's just going to increase cost. You know, a sleeve that goes across here. I mean, it's not a terrible idea, but it's still not. It's not what I want to do. But I don't like having exposed threads. But I think it's just what it's going to be. As it is, if this goes in the AC area, that's going to be under the intake manifold anyways. You're not really going to see it much. What I did here, you see I have these bolt holes on top. That's for a manifold. If I want to tie all 3 suctions together to one manifold, then the manifold has an O-ring surface and, you know, it comes out and I put a hose. It's basically for 90 degree in all of these. I can 90 degree it to a single manifold, like a big dash 16 or something, and have that come into all the suction chambers if I wanted to tie them all together for some reason. It isn't something that this car would need or that I would want to do for this one, but it's just an option. I wanted to keep, you know, future-proofing it, so if I wanted to do that. The other idea, too, was when I moved this over to the other side and then move the pressure to here, was use this front one as just the suction from the bottom of the pan or the turbo, which just sits in the front anyways, which would be kind of cool, too. So my dad's calling me. Let me turn that off. I will call him back. Clearly my dad doesn't follow me on YouTube. What a dick. I need both fingers so I can drag. Or both hands. Anyways, so that's that. I'm super excited about that. And obviously about this guy. So I finalized the stuff. And I sent it over to the machinist today. And production is starting on these today. I'm only getting 10 made initially. I know that's weird to have them done before we got this something made or any of that. But I have 10 of these made. Like I said, for the daily guys. I'm waiting on a friend of mine who has daily kit to send me the dimensions or the pulley. He's gonna send me that stuff so that I can model the right size pulley for the daily so those guys can get off of the timing belt. I really, really, really hate the fact that they drive the dry sump pump off the timing belt. What a terrible fucking idea. In between the cams, no less, right? Like, if it was between the crank and the first cam, okay, I can see that a little bit, but that sucks because it stretches the timing belt and throws off cam timing. But it's both of them evenly. If it was after the last one in the line and it stretched time belt some, oh, okay, it's fine. It stretched the belt, but at least cam timing is right. It's more work for the tensioner, but hey, cam timing's right. But they do it between them on the water pump. And the boss breaks off sometimes and it stretches the time belt in between the cams. So the left side head has different cam timing than the right side head. And to me, that doesn't make any fucking sense. So why not just make a pulley and run the belt up a little further and not fucking worry about it? It's the same plane too, right? The thing comes out the front of the timing cover. So they're driving it in the same plane as this thing. So just put it right here. That's my logic on it. So, oh yeah, and the last thing is, it's only 2.4 pounds. That's a bummer. I wanted it heavier. You know me, I like heavy crank pulleys. So what I did was left it provisioned. You'll see here these holes. These are M8. These are not small holes, right? They're good size holes, and they're deep. And this is a precision cut bore. What I did is, I haven't drawn it in SolidWorks yet, so I can't show you, but I can bolt a weight onto this. I can bolt a weight that's center bores in here. I have 2 O-rings to help seat it in here and to give it some vibration damping and to minimize fretting corrosion. If you know what fretting corrosion is, when 2 dissimilar metals, or even 2 similar metals, rub against each other and they vibrate a little bit and they erode each other's surfaces, and you'll take something apart and you'll see like rust or these weird amoeba shaped traces of rust and like lower height. That's fretting corrosion causing them to like eat each other up, and we don't want that. So, two O-rings that locate this tightly in this center bore, and then this bolts on the front, and I can increase my rotational mass if I need to tailor it for what I'm doing. Or if I'm running a standalone and I want to use a different crank trigger, I can bolt a crank trigger to this bitch and run a 30 minus 1 or 60 minus 2 or an AM24 tooth or whatever I want. I can put a crank pulley on this guy and run that as well. So, and then lastly, I can use a puller to get the damn thing off. If it gets stuck on there, I need a puller. I can use a puller to get it off. So those bolt holes serve many functions, and one of them is to make me not a hypocrite by allowing us to add weight to make this thing heavier. Now, this thing's solid. If you look at the Perrin pulley, for example, it's all cut out and these little spokes and everything to try and keep it light. I fucking hate light pulleys. You guys know that. And since there isn't the second layer of belt, the full height, I lose a lot of material here of what would be a good amount of weight on it. So this whole center hub is solid, and I made it just like the factory one right here, which has got 4 holes in it, obviously, but they're not threaded. So it's solid like that. Boy, this is a lot heavier. Yeah. Any questions about that stuff? I've done a lot of show and tell today. Watch the rest later. Grind down, my man, just like the push rods. Yeah, I'm not going to grind down those threads. I'm not going to do that. It looks like a flute. Oh, sure, a recorder, yeah. ARE sump for comparison as well. I have not looked at the ARE one, honestly, or what's the other one? There's a couple, right? I have not looked at theirs for comparison. I thought about doing some stuff, and I drew some stuff up in SolidWorks of what I wanted, and then I looked at it. I found another company, and I go, motherfucker, they're doing exactly what I'm doing. And I realized, wait a second, I'm the motherfucker, because I'm technically doing what they're doing. Son of a bitch. But it was a good design. That part of it was a good design. So I had already done all this shit like this with the stick out and the threads here and sharing the chambers between the two of them, and I freaking found Barnes, and I was like, son of a bitch. I even emailed the guy and said, here's my dry stuff I'm working on. Can I, get some advice? Can you sell me some shit? I wanted them to sell me the first pumps. I wanted them to build the original pumps. But they were like 8 to 12 weeks out for the first pump. And I don't have that kind of time. So instead I build my own. Mine's more compact though. It's not for an 8-cylinder, right? It's for a 4-cylinder. So I don't need to have this gigantic pressure gear in here like they have on theirs for the 8-cylinders and shit. It's a 4-cylinder. Just turn some RPM, but it's just a 4-cylinder. So I made a 4-cylinder specific dry sump pump. As it is, my initial calculations show I have like 18 gallons per hour, or gallons per minute, 18 gallons per minute from the pressure stage. Now, in comparison to like an LS1 pump, they require 7 point something gallons per minute. So I'm already way over what they produce. And so, oh no, it was 17 without losses. So taking another 10 to 15% off of that. But I'm still well above even what an LS would require. In theory, obviously in theory and practice something different. I may find that I have to increase the losses by opening the clearance between the sides of the rotors and in between the teeth to compensate for all the heat cycles and everything, in which case the flow is going to drop. So at least I'm starting with way above the flow I need, and that allows me to increase tolerances and make things more voluminous and have more and sloppier essentially in between the parts, so that everything can stay cool and not get too angry. So anyways, I appreciate you guys stopping by. I hope that today's discussion was fun. We got to do some SolidWorks stuff, got to do some weird health and visual stuff, got to do Didn't you do gun stuff? Did they do gun stuff yet? Are you guys offended by guns? I hope not, right? So my I just I have a lot of boxes right here in the corner, and it's a fucking mess. I just got guns laying around right now. I just put that one together last night at 1 in the morning, and it's just propped up. So I'm gonna show you my really messy area. Yeah, that's a mess. But those little cardboard boxes right there, those are all gun holders and stuff. I just got them in the mail the other day. Um, they're actually made in China. One of these made in China, and it's hilarious because on the box it says plastic phone case. Let me show you. This is funny. Rubber phone holder. That's what it was. Rubber phone holder. And then you open it up, and it ain't a phone holder at all. It's right on it. PMag AR-15 6X. So it's a mount that holds 6 PMags on the wall or on whatever. But it's a rubber phone holder. I think the Chinese fucking know that California sucks. And so they're like, we need to ship stuff to California. We better put rubber phone holder on here. And so the one I just got last night, or yesterday, the one I didn't even open, right away, I think this rotate device, is this guy. So this one, which is hard to see, is an AR-10. It's a Palmetto State Armory, their Gen 3 version AR-10. I wanted to give one of their uppers a shot. I have a couple of their lowers that I liked for other guns. I don't like it for the AR-10 unless you use it with their AR-10 upper because they add some weird geometry in here that doesn't fit at all. I had an Air Precision upper on here, and the Air Precision upper and this one looked like absolute ass. They don't match at all. It was horrendous. It hurt my eyeballs. This one actually has a little bit of error in the back. I don't like. I wish it fit a little better. Yes, Travis. I've always wanted to come back home to Idaho. I fucking hate everywhere else. Not everywhere else. Most other places. But, so yeah, this Palmetto. I actually like their grip. I'm not going to lie. It looks like a regular grip, but it's rubberized. It's a rubberized A2 grip. It feels super good in your hand. The tactile nature of it. Let's grab it here. Indexing. So the tactile nature of the grip is really nice. Yeah, there is a lot of PSA hate out there. I mean, they got some shit that's pretty jank, so that's expected, I think. But this grip, it's rubber. It fits really nice. Everything is trashed by a good file. I mean, yeah, the FAL is fucking sweet. You know, a nice Scar would be sweet if I could afford a Scar H or something, right? Who doesn't want a Scar H? I mean, I got that one up there I built. That one's a AR-10 chambered in 338 Federal. That thing's freaking sweet. I love that thing. If you don't know what that is, so this is 338 Federal. That's the standard 308. But you can see here the Bulle is quite a bit meatier than the regular 308. Case the same size, same parent case. All they do is neck it up to 338. And this thing shoots freaking awesome. It's a good case. It's a good chamber of a good cartridge. I mean, I'll figure out the words I want to use. It's a good cartridge. It has pretty decent ballistics. Out of that gun, up to 600 yards, it was hitting pretty much where it calculated with just shelf ammo. I was really impressed with it. So really cool. It did a really good job. I liked it a lot. Just I was having issues with it feeding, and that turned out to be right here. If you look, the tip of that, when it's going, when it's feeding itself, it often hits the end of the PMag right here and gets stuck and doesn't feed up properly. So I have to like open this up a smidge, the PMag up a smidge right here to allow them to ramp into the feeders well. They just get stuck on the end of the PMag. Because they got this flat tip, that's really shitty quality. There it goes. Because of the flat tip, it doesn't slide past the end of the mag correctly. Like, cause it usually sits like right here. There you go. See, it's on the low end, so that's kind of low like that. Whereas the 330 or the 308 comes to a really fine point, and that fine point has no problem in getting past the end of the magazine. So that was creating some feelings. That and my freaking gas port was the wrong size. So eventually I fixed that. Oh, shit balls. I think that's all the exciting stuff I have. I've already showed you guys my favorite gun, my BRN 180S. If you don't know what BRN 180S is, look it up. It's really cool. It's based off the AR-18. I like it a lot. And I got to shoot the other day. I really, really like it. I like it a lot. I hate the rear charging handle on ARs. I think that is the stupidest fucking design of almost any gun. The rear charging handle is fucking lame. And so I really like guns with side charging handles. I like ARs that are converted to side charging. I have Bear Creek, another really cheap company. Bear Creek Arsenal, something like that. They have a side charger, and that I like a lot. It could be done better, but it works, and it's a side charger, and I love that. The BRN 180S, based off the AR-18 or the AR-180, which is the civilian version, only it's not sheet metal like the 18 and the 180 were, and it's made to fit on a 15 lower, is really sweet. It's extremely smooth. The charging handle and everything is ergonomic, and it's super smooth. It's quiet. It fires at a decent rate. It's very comfortable to shoot. I like it. And you don't have that spring in the back going in the back of the buffer. I hate that spring. Sounds like you're dragging a cinder block across concrete, and there's a cat that was sleeping there, and you hit the cat with it. And just terrible. So I love the BRN-80S because it's on the bolt carrier group is on 2 guide pins with springs. There's no buffer tube, none of that shit. It's just smooth. It's side charging. It shoots really nice. That's really cool. My only regret is that I didn't get 2. I got 1 in the 10.5-inch pistol length, and now I wish I had 1 in the rifle length because it shoots really nice, really, really nice. That's it. Those are my 2 favorite ones lately. So, all right, I got to go back, finish this drawing, and then I need to go work on the car. And then it's 100 and something degrees outside though, so tuning doesn't really happen, doesn't work very good in this kind of heat. So I won't have any dyno tunes this week. I canceled them all because I'm not trying to have everyone's car fail, right? And I'm not trying to add, 64 ounces of my bodily fluids to the seat of their car. Yeah, right. Lots of water. Subi loves to drive. Yeah. So what were we thinking? SA-58 or something? We said give that fail. Is that SA-58? Is that what they're called? Those things are pretty cool too. Anyways, thanks guys. I'm gonna go do this stuff. Hope you guys have a good day. Maybe tomorrow I'll stream a smidge showing you what I'm working on. It's just that 240 with the Turbo KA. I like the car. Just I think he's having EMS issues. It's dropping spark. It's not getting output to the coils correctly. And it does it based on heat and load and that kind of stuff. The scent provides added value. Yeah, well, usually that's when I have cheese beforehand. And then I total the car before I finish the tune. Yeah. See you guys. Have a good day.